innovation is really what drives growth in an economy, and the spillovers from that just reach into so many corners of the economy. That's why it's so important. I think in this country, we haven't necessarily recognized how much innovation happens in that manufacturing scale-up side of the equation.
We're currently facing the biggest industrial challenge in this country since the Second World War. The challenge of managing an energy transition to clean, carbon-free power. We have to electrify our nation. We have to completely overhaul our electrical grid. We have to make it smarter. We have to connect it to renewable energy. That renewable energy needs to be carbon-free, and it also needs to be dispatchable, meaning available 24/7. So we have to build new energy systems. We have to build new transportation infrastructure. We need to have electric vehicles, not just cars and trucks, but also buses and trains. We need to have carbon-free aviation and shipping. And we have to change the way we manufacture concrete, steel, everything. So there's a lot of work that's needed. It's going to require a great deal of innovation. It's going to take ingenuity, and it's going to take good old American manufacturing know-how. Over the past 25 years, we've offshored so much of our manufacturing for the purposes of cheap labor and resources. But we've lost something in the transition. We've lost the know-how that comes from being on the floor and watching the products get built. To basically revisit our ability to innovate, we need to repatriate our manufacturing. We need to be in the room when it happens. We need to be able to understand what's going right and what's going wrong. When you're building something, when you're in the room, you see problems and you figure out how to fix those problems. And those fixes are inventions, they're innovations, they're discovery. They're what makes your products better. Today on Good Clean Energy, Professor Willy Shih from Harvard Business School talks to us about how the Inflation Reduction Act is influencing manufacturing in the United States, bringing it back to our shores, and how it's going to drive our electrical transition, our clean energy transition, and how it's going to make an opportunity for us to innovate again, which is actually America's superpower. Dr. Willy Shih thinks that America needs a manufacturing renaissance, not solely for the reason that it's great for our economy to have good local jobs that pay well, but because of what it does for us as a people in terms of teaching us how to do what we do better, to build better products and to innovate. We need to innovate in energy, and we need to innovate in the way we think about our economy, and we need to innovate in the way we think about climate change. I'm your host, Jim McNeil, and this is Good Clean Energy. Professor Willy Shih, welcome to Good Clean Energy.
Thank you for having me.
I'm really excited about having this conversation because we've been learning a lot about the Inflation Reduction Act and its impact on U.S. economy and our efforts to deal with climate change. And also, there's a lot of stuff in the news about supply chain and onshoring manufacturing, and this seems to be your primary area of expertise. So over the past 2 decades, we've moved a lot of manufacturing offshore for lower labor costs and lower resource costs, and this has had an impact on the U.S. economy. I mean, do you think we've lost our competitive edge as a nation?
One of the things that I think has happened is as we've moved production offshore, we've lost a lot of the capabilities to make those things. Now, it's a mixed bag because on the one hand, offshoring has helped reduce inflation over, say, the last 15 years up until recently, and they've brought us a cornucopia of inexpensive products. So a lot of people have benefited from that. But of course, the people who lost jobs as those manufacturing operations moved offshore, that had a heavy impact on them. But more critically, and I think we've come to realize it lately, the country has lost a lot of capabilities for things that we might think are very important strategically.
Well, I guess a good way to talk about this is that there's a concept of innovation and manufacturing kind of go hand in hand.
I think in this country, we haven't necessarily recognized how much innovation happens in that manufacturing scale-up side of the equation.
Do you have any thoughts on the IRA and what that's going to mean to our mobility, clean energy transition?
Well, I've always been skeptical about industrial policies because it's been challenging to get these things right. And I've also been skeptical about the ability to reshore production from a low-cost country to a high-cost country. If you think about the economics of reshoring, when you move from a high-cost country, like we did a lot in the early 2000s, when you move from a high-cost country to a low-cost country, you have to build a factory, you have to hire management, you have to hire a workforce, you have to move the supply chain in, and there are a lot of costs associated with that move, but the costs are paid for by the savings and product costs that you realize because now you can employ labor arbitrage and you can produce in a low-cost country. So it works when you move from a high-cost country to a low-cost country. The question when you move from a low-cost country to a high-cost country is who's going to pay for that? Now, I think the Inflation Reduction Act has two types of incentives that are actually uniquely paired to move a lot of that production back. Okay, so the IRA includes supply side incentives, which include tax credits and subsidies for building new facilities in the United States. And then it also includes demand side incentives. So, for example, there is credits for the purchase of electric vehicles that have domestically produced batteries and components. Okay, so that has had a major effect because not only do you provide the subsidies to companies to build factories, but then they have a reasonable assurance of customers coming to them to buy products made in those factories because they want the domestic content. So I think IRA is pretty unique in that combination of supply side and demand side incentives, and it's had a really powerful effect. I think back in 2020, at the end of 2020, there were about 51 billion in announced domestic EV and battery factories in the U.S. compared to 115 billion that were announced or under construction in China at the time.
Yeah.
But thanks to the IRA, but also the Inflation Reduction and Jobs Act, the U.S. number jumped to 210 billion by January of this year. So now all of a sudden we went from lagging China in terms of new factories to well ahead of China. So, boy, that was a game changer in my book.
That's a big game changer. Yeah. So Mercedes is going to Alabama. BMW is going to South Carolina. Hyundai is going to Georgia. I'm just talking about battery plants.
Yeah, battery plants, right. They are locating close to their vehicle production facilities, right? So we've seen a lot of new announcements in that regard, and it demonstrates the power of these incentives. Now, the theory of the case on the incentives is that I'm going to give you a kickstart on production because all of these new factories, when they first come on stream, their initial costs are going to be very high. Okay. And what they have to do is they have to come down a learning curve. And so I would argue that the theory of the case on incentives is I'm going to give you these subsidies during your startup period. Then you need to come down the learning curve, but eventually you need to be able to stand on your own because your production costs have come down.
Yeah, well, the incentives are quite substantial. I mean, you're talking about $35 per kilowatt hour, for cell, 10 for the pack. So if you have a 100 kilowatt battery in a car, you're talking about a $4,500 subsidy.
Those are huge subsidies.
And people don't appreciate that the margins on autos are not as big as they might think. $4,500 is a game changer, right?
Well, that's why we've seen first all these new factory announcements. And I was actually over in Europe earlier this year, and people there were up in arms because European suppliers were saying, wait a minute, these incentives are so rich, I'm going to move to the U.S.
Yeah. Well, and also, I guess they were originally blocked from it, and then there was a tweak to the rules that made leases qualified for these incentives from foreign EVs, right?
Right. The legislation came out first, and then Treasury has to rule on how these things are actually going to be implemented, right? So it's all in the details, and there's rich detail in that, but I think a lot of lawyers are studying it right now.
Yeah. And I think currently you have to have 50% of your materials sourced from the U.S., and that goes up 10% a year, up to 100% by 2029.
Right.
So that's another factor, to support onboarding in the United States.
Right. And like I say, the theory of the case is that you will be able to get your costs down in that time frame, and you'll be able to be competitive in your own right when the subsidies end.
Right. One of the things I was reading about in terms of what you've been studying is innovation drives economy. Is that a fair statement?
Well, I think innovation is really what drives growth in an economy, and the spillovers from that just reach into so many corners of the economy. That's why it's so important. That's why countries around the world really have invested in innovation.
Right. And innovation's traditionally been sort of America's superpower as a nation.
After World War II, America really led the way in innovation, and it stimulated investments in many other countries around the world, Europe, Japan, across Asia, and South Asia now as well, where people have realized the long-term importance of investing in the basic research and innovation.
What do you think are the real opportunities in terms of the U.S., again, asserting itself as the leader of innovation? Do you think there are categories or factors where we can have an impact?
I think the thing that makes the United States really unique is, first of all, it is the world's richest market. So that means that in itself represents consumers who will buy innovative products and services. Okay. And that's a very important component. As the world's largest market in the second half of the 20th century, it served the U.S. extremely well. I think the opportunity for the U.S. is in some of these new technologies as part of, for example, the energy transition. The fact that the U.S. is now taking the green transition seriously, we're seeing huge investments in things like hydrogen, carbon capture, more sustainable transport, a large number of areas, right? So I think that's an opportunity for this country where we haven't necessarily had that initiative before.
Are you familiar with the increased investment that's gone into the fusion market?
I have watched a lot about the fusion market. I think one of the things that is really coming into focus a lot more is the challenges we face with climate change, and we're seeing the impacts of it more on a daily basis now. So I think more people are taking it seriously. And what I think makes some of these sectors very interesting is there are some hard to decarbonize sectors that require enormous amounts of energy. And I don't think people fully appreciate how hard it is going to be to do everything just with, for example, just with hydrogen. Okay.
Or wind and solar.
Or wind and solar. I visited a steel mill last summer that's trying to go to direct hydrogen reduction, direct reduced iron with hydrogen. And they're going to require an enormous amount of electrical power to do that. Now, the domestic steel industry is actually relatively green compared to others around the world because we make so much steel out of scrap, right? And when you're using scrap as a feedstock, the energy that was expended in reducing the iron ore initially, that was already expended. So it's relatively green compared to a lot of the primary metal producers, for example, in Asia or Eastern Europe. But not all steel comes from scrap. You still have to make some of that virgin metal
right
from iron ore. Okay. And that direct reduction is a good technique. I think there have been steps that the industry has taken, for example, moving to direct reduction using natural gas. That hasn't been implemented that much in the U.S., but it has taken off much more in other parts of the world. But there's still that, where am I going to get that base metal from iron ore? And that's a huge carbon source. So replacing coking coal with hydrogen or
clean energy.
Yeah, clean energy. That's is a big challenge, but it's going to be very important.
Well, the private fusion industry has received just over $5 billion in the past couple of years, and there's much, much more coming into it. And I just was wondering if you could think about the fact that energy is such a significant input into the economy and GDP. And if we could reduce the cost of energy without even a carbon tax in the conversation, but just reduce the cost per kilowatt down into the single digit, pennies per kilowatt section, because the cost of a fusion power plant is the materials and the know-how it takes to build the plant. The cost of operation, the fuel is negligible because they're dealing, in the case of TIE, hydrogen and boron, case of others, hydrogen and helium, others, deuterium and tritium. Compared to oil or coal, these costs are very, very low. Can you see a scenario where we transition the world from fossil fuel-based energy to fusion-based energy? We need about 10,000 plants to do it, to get from the current electricity demand we have today to what's projected in 2050. What kind of impact do you think that could have on the world? And what would you say if the U.S. led that charge?
Well, I think that's always been the promise of fusion in my mind. I think people in general don't appreciate how significant cheap energy has been to the development of the United States and the development of industrial economies around the world. Now, I learned this in perhaps an unusual way because one of the things I do is very small scale farming. And so I live in New Hampshire and we have to move a lot of rocks and it's tough work, but I have a tractor. And I really came to appreciate the role of cheap, inexpensive energy when I realized how much work I can do with 1 gallon of diesel.
Yeah.
Okay. And, we drive around and we use a lot of gasoline or diesel, or we fly around and we use Jet A. And what we don't appreciate is how much of that energy we put into wind resistance or rolling resistance for moving that amount of weight. But me with my little tractor and a gallon of diesel, I can't imagine having done that with manual labor, which is what the settlers in the U.S. did, right? And what it did is it gave me an appreciation for kind of the energy content in so much of what we do, right? Otherwise it's just numbers, but for me, that really made it real. But you look at metals like aluminum, okay, metals like steel, titanium, tremendous amount of energy content in them.
Or concrete, for that matter.
Or concrete, or making paper, right? All of these things have a tremendous amount of energy content. The steel mill that I visited, it was a medium-sized mill, and I was trying to get a handle on how much energy they would need to do hydrogen-assisted direct reduction. This is a medium-sized mill. They need basically the electricity from a Niagara Falls just to supply a single medium-sized mill.
Wow. And we're not about to put a, hydroelectric dam at Niagara Falls, I don't think.
Well, we don't have that many Niagara Falls either.
So if we can get to, as you said, and I think it's an appropriate term, cheap energy, which, as you also pointed out, the U.S. has enjoyed for the past, 150 years in a very significant way. It wasn't really until the 70s where we got the kind of shock of what would happen if we didn't have access to inexpensive oil. But to move to a future where we have carbon-free baseload power that's pennies per kilowatt, there's two things that are going to happen. One is you've got the economic boon of deploying these clean power plants around the world, which is going to stimulate a lot of economy. And then number two, the impact of that abundant energy going into each of the countries that utilize this technology. That's going to have an impact on our economy, is it not?
Yes, I think it will change the footprint of where a lot of these capabilities are located. Now, even before we get to fusion power, I think we will see that already with, for example, offshore wind. If you look to the Baltic countries in Europe, Denmark, Sweden in particular, where they're making major investments in offshore wind, a lot of the discussion is about direct conversion to hydrogen at the wind turbine, and then what kind of industries might locate near there because you have inexpensive energy or inexpensively produced hydrogen.
So you're saying instead of pumping electrons from the turbine, you're going to pump hydrogen to the shore?
Well, I was visiting Port Esper, which is on the west coast of Denmark, and they are the primary integration site for offshore wind for Northern Europe. So, North Sea and Baltic offshore wind operations. And just the cost of running cables to all of these offshore turbines is very, very high. Plus you have losses there.
Well, you need a lot of cable if you're running, these turbines they're in the megawatt range?
They're typically the large ones are 8 megawatts now, and they're going up to 14 megawatts. So
yes, you need a lot of copper to carry that kind of power.
Well, I think somebody told me that the cable that you needed was, I don't remember the exact number, but was in the thousands of euros per meter.
Wow.
Okay. And it's not only the cable, but it's also the conversion efficiency and the losses that you run.
Well, yeah, because you have impedance, and so you're going to lose energy as it goes through that wire.
Right. So you have the losses. So they're actually looking at, well, should we convert it to hydrogen at this offshore island, or should we even consider converting it to hydrogen at the turbine? There are companies who are looking at doing things like that. I know Toyota has been a big proponent of hydrogen for vehicles, and I've talked to them about that, and they seem to have addressed the safety issues. When energy density is important, that means I need to not take up a huge volume to transport the hydrogen, and you think about going to liquid hydrogen. I think that's a whole different game because it's much harder to transport, much harder to store.
Well, they're talking about 5 kilograms of hydrogen in a 300-mile range on a hydrogen combustion engine that they're already testing from Toyota.
Yeah, they're doing that with the compressed storage. They've been working on that for a long time. They have a lot of experience with that. They've long believed in a more diversified energy supply than just pure battery storage.
Yeah, I think they believe kind of the right solution at the right time for the right customer, right?
Yeah. I mean, one of the things they point out is with lithium batteries, when you go to colder regions of the world, you lose a significant amount of capacity, right? And you don't with hydrogen.
That's a very good point. Yeah, if you're living up in Norway or something, you're probably better off with a hydrogen vehicle than you are with the Tesla.
Or many parts of Canada.
Yeah. Or where you are in New Hampshire.
Well, with global warming, it's getting warmer.
You're the future San Diego, Willie.
Yeah, we have rocks instead of sand, though.
Your farming thing reminds me of reading East of Eden, where the guy was so sick of pulling rocks out of his Connecticut fields, he just said, to hell with it, I'm going west.
That's why people move to the Midwest. That's right.
Do you see a future where the U.S. can maintain its position as the number one economy in the world, even though we're competing against 1.3 billion people in China and they're really close on our heels? Do you think there's a possibility that we can maintain that position?
Well, I think the U.S. has many advantages. Okay. One, as I said earlier, it is a large market. I think the U.S. also fosters a competition of ideas. And when I say competition of ideas, that also means Schumpeter's creative destruction, right? Which is the reallocation of resources from ideas that may no longer be so great, okay, or may have gone obsolete, to new ideas. Okay, that's what the U.S. is really good at. We're still the heart of innovation. We value that kind of market competition. And I think it's very hard for planned economies to compete on that basis. Even in semiconductors, when we bemoan the loss of a lot of the manufacturing, a lot of that value chain continues to reside in the United States in terms of hardware and software tools, design innovation, architecture, things like that. When you look at what's going on in generative AI and large language models and stuff that rely on large scale computing, a lot of that stuff still comes from the U.S., right? So the strengths of the U.S. are really in our market system, competition of ideas, willingness to reallocate resources from failing or older things to the new. Okay. And to the extent we can play to those, I think the future is bright.
Well, one of the other things I've noticed in my travels around the world in business, that's unique in the United States is the number of entrepreneurs we have and the access to capital.
For sure. And that's because we value that competition of ideas. And by the way, many of those startups fail.
Oh, most of the startups fail.
90% fail, 90+% fail.
Yeah.
And then those resources get allocated, and then the winning ideas get selected by the market. That's our strength. Not having winning ideas be selected by the government, but have them be selected by the market.
We have a lot of shots on goal. Most of them don't go in, but the ones that do make a difference.
Right. It's like quantity has a quality all its own. That's a terrible quote. I think it was from Joseph Stalin.
Yeah, it may not be great to quote Stalin these days.
Yeah, you probably don't want to do that.
But no, I think it's actually, when you think about that quote in the context of Russia and Soviet Russia, it makes a lot of sense.
In the context of ideas, yeah, when you think about, in the U.S., we try a lot more things, okay, and a lot of things fail, but the things that are successful have been tested by the market.
I'd have to go back. There was a trend that was going on when I was in private equity where we would annually kind of look at the dead pool,
yeah,
which were, all the failed startups for the year, and we'd kind of review, what happened. It was a very interesting post-mortem practice.
Yeah, there's a lot of learning from that.
You are somebody who knows a little bit about supply chain, and we're just talking about the abundant resources of the United States historically, and this new manufacturing initiative in the IRA, which is that we're going to source materials from the U.S. Is this something that's going to happen? I mean, we have so many regulations about, digging holes and extractive mining and so forth. Are we prepared to go back to a mining mindset and do so, environmental responsible ways?
We haven't demonstrated that at a large scale yet. We are very slow in building new facilities, even if it's something like a semiconductor fab or some expensive project. We tend to cost more and take longer than any other place in the world. Now, let's take a $20 billion semiconductor fab. Okay. And then you look at how much equipment you install in there and you say, well, how much depreciation charges am I going to face per day? Okay. Let's say it might be something like $30 million a day. That means my investment, I need like $1 million an hour of cash flow just to cover that investment. Okay. So you go over to Asia and people are saying, man, I need $1 million every hour I can get it sooner. I'm covering my costs, right? So they'll be pouring concrete on Christmas Day. And they'll be doing construction on Christmas Day. Whereas in the U.S., we would never consider that. Rather, it's like, let's have another hearing. All right.
You're saying we don't have the mindset that you would have in a benevolent dictatorship?
Well, it's not a benevolent dictatorship. You go to Taiwan and they do this as well. Taiwan is a democracy. What it is it's a mindset where delay costs me things. These days in Taiwan, they're environmentally responsible as well. Okay. But they understand the cost of delays. I don't think in this country we really appreciate that delay is money.
Well, I think when you couch it in the terms that you did, which is $1 million an hour, that certainly makes it's quite sobering when you think about it that way.
I use that example as a hypothetical example, but people don't really think about, gee, what is this costing me per hour of delay? It takes twice as long, at least, to build a semiconductor fab in the U.S. as it does in Asia. And a lot of these investments, when you look at how long does it take me to get a grid connection for a new solar farm, it could be years.
In some cases, it's been 17 years.
Yeah, it's crazy, right? And it's like, we want it, but we don't want it badly enough.
So is it the political will? Is it lack of political will? Or is it the fact that we are at loggerheads in our politics?
I think, I want to be careful how this is interpreted. It's like for every one of these things, there are lots of different interests. There are, if you look at Cape Wind, there were people who didn't want their views spoiled.
Sure.
Okay. And so there are lots of different interests. And we live in a democracy. So we think it's important to hear everybody's interests. Okay. And there are other parts of the world where people will say, get out of the way.
Hey, there is value, by the way, in having, like you said, obviously a democracy where we listen to people's opinions. I mean, you are obviously a well-traveled person.
And I wouldn't want to live anywhere else. I've been to countries where we're going to build a dam here. You million people, move. Okay?
Yeah.
And I wouldn't want to live there. But there's a balance somewhere in between those extremes, right? Because taking 17 years to get a permit is like, why would anybody want to do that?
Well, they don't. I mean, they never would if they knew it would take 17 years. You know, you talk about small modular reactors. The technology and the science is much more advanced than the regulations that are going to be required to implement these facilities.
That's right. So I think we just don't talk about the cost of those delays in this country.
Yeah. No, I think it should become much more apparent. So let's jump forward to your view of the future. What do you see as the future for the U.S. economy and for the world in general? What kind of vision do you have for our future?
Well, the most important vision would be to slow down global warming. All right. It'll be a healthier planet, a healthier place to live. I think inexpensive energy will really unleash a lot of new growth in many, many areas, right? I mean, inexpensive energy is obviously important for physical products, but it's important for agriculture. It's important for making lives better across the board. So it will be almost like going back to an earlier time when we saw a lot of growth in this country that was fueled by wide open spaces and inexpensive energy.
I really appreciate your time today. I like your insights. I like your perspective. And I also like the fact that you're a Harvard Business School professor who's actually worked in business for over 25 or 28 years, I think. So it's a very refreshing opportunity to talk to somebody who's actually worked in business and doesn't just teach it.
Well, thank you. I think it's valuable because then it gives you a very different perspective. You know, too many people, if you stick with a theory, you don't understand what it means to make a payroll.
It's very true. Couldn't agree more. Willy, thank you very much.
Thanks for having me.
Thank you for listening to Good Clean Energy.